All right, hello, welcome. This is day 2 of Exponent Rules, and we're still going to be using our rules from yesterday, like the zero and negative exponent rules, but we're going to learn a couple new ones today. One involving like division, when you're dividing and the bases are the same, and then we're going to do one kind of like a distributive property rule when you have like an exponent on the outside. We talked a little bit about that yesterday. We actually distributed in. And then kind of a similar one, like if you have a fraction, and then you have an exponent out here, talk about how to deal with this one. And it actually kind of just distributes in sort of like this second one here, but that's what we're doing in this lesson. So the first one is when you divide. And what I kind of do here is just like expand. So I think of x to the fifth like that, and x squared, sorry, that's a bad line, as x times x. Sorry, there's x to the fifth, there's x squared. And then what happens is they just cancel out. So you like cancel out a pair of x's top to bottom, and then you're left with x cubed up at the top. Okay, but hopefully like you realize the rule is actually you subtract, right? This one's x, 5 minus 2, or x cubed. Okay, but I do kind of like this expanded form, because if we look at this one here and we subtracted them, we'd have like d to the negative sixth, which is kind of a pain because then you got to flip it. So like what I would do on this particular example is I just think of it as like d cubed is like that, and then d to the ninth is you have 9 of them. 5, 6, 7, 8, 9. Sorry, that's kind of obnoxious, but basically then you cancel out. Okay, and then you end up with just d to the sixth on the bottom. Okay, which again, you could have done 3 minus 9 to get d to the negative sixth, but then you're going to end up flipping it or moving it down to the denominator. So to me, that's kind of cumbersome. I like just to think if you have 6 more d's on the bottom than you do on the top. Okay, and then the rest of this, the 8 and the 4, just divides to 2 and 1. So you get a 2 and then a times 1 there, but the times 1 really doesn't mean anything. So this thing cleans up to 2 over d to the sixth. Okay, so here's kind of a wild example of this. And before I let you go here, I give you some hints. You can subtract the exponents like we did on the previous one. Might be the easiest way here. Otherwise, you could try to move around some of the negatives. You end up moving a lot of stuff there. So I don't know how you want to do it, but maybe pause the video and give this a shot. All right, so I'm not sure the best approach to this, but let's try just doing 16 divided by 4. That's 4 and 1. And then for the m's, let's just try our subtract rule. Right? I kind of do expanded form when the exponents are positive, but when they're negative here, I'm tempted just to use the rule. So it'd be m, and then we do 4 minus negative 2. So that becomes an m6 up top. And then for n, oh man, again, you could minus some, you'd get n. Maybe I will minus them. I'll just get n to the minus, let's see, minus 4. It'd be n to the 3 minus 7. Okay, and eventually it's going to move back down, right? Like, honestly, in my head, I just write n3 in the bottom because I know there's 3 more n's in the denominator than the numerator. But if we're doing the rules, it'd be minus 4, and then it'll move down here in a second. And then for p, it'd be p to the negative 3 minus negative 8. So that's going to be like negative 3 plus 8. The minus negative becomes a plus, so we have p to the 5th. Sorry for the bad handwriting there. Maybe I'll try to write it a little clearer. P to the 5th. Okay, so that's kind of step 1. And then the next part is, again, like we already talked about, move the negative exponent down. So we have a 4 and m to the 6th and p to the 5th. Those are positive exponents. Keep them up top. And then the n to the 4th moves down. And then that would be our final cleaned up answer. Okay, next up is called a power of a power rule. And I want to use expanded form to make sense of it. So this 2 here means we have 2 parentheses. So I'm going to draw 2 parentheses. And then inside of each parentheses is 3 to the 4th, which is 3 4 times. Okay, so if we expand it out, it looks like that, which means we have a total of 8 3's multiplied. So it's 3 to the 8th. Okay, and sort of the rule ends up being you just multiply these two. Okay, but if you forget that, you can always use expanded form. Because there's a lot of rules to remember, and like, I don't know, it's easy to mix them all up. So if you get stuck, especially with positive exponents, I would expand it. Okay, so like in this one, we have 2 of these parentheses again, and each one you have 3m, so that's 6 m's total, so it's m to the 6. And again, the simple thing is you just multiply, but again, if you forget, and it's positive exponents, expand it out and see what it looks like. Okay, so here's a couple of them for you to try. All right, so on this one, it sort of distributes in. So you get 4 cubed times 4 x cubed, and then 4 cubed is 64. 4 times 4 times 4, and then x cubed. So this one cleans up to 64x cubed. And again, what I mean by expanded form is like this little 3 means you have 4x times a 4x times another 4x. And that's where you get 4 cubed and x cubed from. And then that again is 64x cubed. So I only do this if I'm stuck. Otherwise, you can just, do the rule. So on this one, if we distribute it in, we end up with 2 squared, x squared, and y squared. So we end up with 4x squared, y squared is what that cleans up to. Okay, last rule here is basically kind of like distribute, where if you have an exponent on the outside of a fraction, it distributes to the numerator and the denominator. Okay, so looking at this example here, this would be like, I guess here's another example of it. You distribute this 3, so you end up with 3 cubed over 5 cubed, and then 3 cubes 27, and 5 cubes 125. Okay, so looking at this slightly more advanced example here, we would take a w to the 5th and put that to the 3rd power over 4 to the 3rd power. So in that way, this 3 got sort of distributed to both the numerator and the denominator. Okay, and then using our power of a power rule here, this would become a w to the 15th, multiply the 5 and the 3, and then 4 cubed is just 64. So this cleans up to be w15 over 64. Okay, so here's another example for you. There's lots of routes to go on this one, so pause the video and give it a shot. Okay, so my gut reaction here, honestly, is like it's tempting to want to distribute this in right away, but I would actually simplify this fraction. And what I mean by that is like 12 15ths, those are divisible by 3, so I would make this 4 fifths. And then a p cubed over a p is that rule where you subtract them. So you actually end up with a p squared. With the idea being, again, if you expand it out, you could cancel out one p and you end up with just a p squared on top. Okay, so now that we got that, now I would actually do my distribute rule, or keep doing expanded form if you really want to. But basically at this point, the 4 is going to distribute to everything. So we have 4 to the 4th, p squared to the 4th power, and then over 5 to the 4th power. Okay, and so now a calculator helps a little bit, because I'm not even sure. 4 to the 4th, I think, is 256. And then you multiply there, so that's p to the 8th, power of a power. And then 5 to the 4th is 625, I believe. Okay, so this whole thing cleans up to that expression. And you could have just distributed it all right away too, but I think it's a little bit easier to simplify the fraction. Okay, next example. This kind of mixes in some stuff from yesterday because it's got a negative exponent and a few other things, so pause the video, give it a shot. Okay, so my gut on this one, how to start, is this negative exponent on the outside means flip. Okay, when it's outside, it means just flip the whole fraction and make it positive. So I'm going to put the d squared on top, and then the 3c to the 3 on the bottom, and now it's a positive exponent. Okay, from here, now I would distribute in the 4. Okay, now that it's a positive exponent, distribute it in, and so we end up with a d to the 2nd to the 4th, and then on the bottom we have 3 to the 4th and c cubed to the 4th. And that gives us d to the 8th up top. 3 to the 4th is 81. And then here is our power of a power again, so that's c to the 12th. Okay, so that's what that thing cleans up to be. Okay, another one kind of similar to that one, but that actually started a little bit different. So pause the video and give this a shot. Okay, so this one I would say you can either flip it right away, would be just fine, or you could actually clean up this middle part. So I'm tempted to do that first, actually. Like, this just cleans up 6 divided by 3 is 2, or 2 over 1. And then an x squared over x, you can cancel that out and you just have an x up top. So that's actually really nice because we got rid of the denominator. It's just a 1. Okay, now maybe I would flip. So I'm going to flip it all, make it positive. And then, again, you can expand this out. I'd actually like to expand this out, right? This is what I would do in my head. Anytime I have a positive exponent, this is what I like to think of it as. Okay, so that just multiplies to 1 on the top, and then 2 times 2 times 2, 8, and x times x times x, x cubed. Okay, so that's what this cleans up to be. If you got here, you can also distribute it, right? You'd have 1 cubed over 2 cubed times x cubed, and then that'll get you the same thing. 1 cubed is 1, 2 cubed is 8, and then just leave the x cubed. So kind of different routes, but with positive exponents, to me, expanded form is super helpful because otherwise you got to memorize all these different rules, and if you can't remember them all, expanding them out is nice. The only thing is expanded form is not great when you have a negative exponent. Okay, so I'm kind of running out of time here. I'm going to make a part 2 video with a few more examples. So I'm going to pause for now and then make another video.